Hi, I'm Paul Brody. This is my shop. Mitch is behind the camera. Welcome. We're doing something a little different this episode. I'm not going to make anything or fix anything. We're going to talk about the Whippet that I made back in 2011, 2012. There's a little story. I was teaching Frame Building 101, and when my students attended class, they had a project. They were going to build themselves a frame, and I wanted to say that I had a project too. So I have a book. It's called Bicycles and Tricycles. You might have heard of it. It's 1896, Archibald Sharp. It's got a wealth of information in it. On page 296, that's where the Whippet is. So that's where I found this bike. And every time I looked at the book, I'd always spend extra time on that page because it had a marvelous shape to it, and I didn't really know how it worked. It took me quite a while to figure it out. And it's a full suspension bike, 1888. So I decided that I was going to undertake the bike as a project, and I knew nothing about it except for the drawing in the book. So I decided that I was going to make a black bike, and it was going to have Shimano parts on it, black Shimano, and maybe even disc brakes, just to be cool. So I started making the frame, and I think I got the head tube done in a tube. I think I had this much here. And then we had an open house, and a friend of a friend came by, and he said, you know, I think the University of Ottawa has one there. Maybe you should contact them. So I made a phone call, I believe, and I talked to someone, and yes, they did have one. It was up in the mezzanine, not on display. It was under plastic, and so I asked a big favor. I said, I'd like to build a bike. Could you take some photographs of it and really up close shots of all the major parts? So they sent me some photos, and I got them, and I realized then that it was much more elegant and sophisticated than I had ever thought. And I decided that I couldn't put on black Shimano parts and disc brakes. I had to do it some justice. So that's when I decided to build it as it is, as a replica. Now, at this time, I became aware of NABS. That's the North American Hand-Built Bicycle Show down in the US. So I talked to my boss at the time at the university, Rolf, and I said, there's a show and I'm building a bike. What do you think? So he said, okay, let me talk about it. So he came back to me and said, yes, if you build the bike, the university will pay expenses, so it'll be airfare, hotel, and the booth. So at that point, I realized that I'm building a bike for NABS. I'm going to have the bike there with all the best frame builders in the world, so I really had to kind of up my game, so to speak. So the bike took about 5 months full-time to make, and when I was finished, I really didn't know what to expect at the show because I was too close to it. I'd worked on it every day. So we went down to the show, and apparently people really liked it because I won People's Choice that year. So that really kind of helped my career as Frame Building 101 instructor. It's 1888. Actually, these bikes were made from 1885 until 1888. It's full suspension, but when you think of full suspension now, you think of young men, women leaping off boulders, going down cliffs, things like that. This was full suspension, but not in the same way. It didn't have air in the tires. It had solid tires, and the suspension was to absorb the shock from the cobblestones and the roughness of the roads. The roads were not in good shape like we have now. They were not smooth. So that's what it did. So it took me a little while to understand how it works. It's got a bunch of pivot points. There's actually 7 of them. So there's one here at the back axle. There's one in behind the bottom bracket. That's number 2. There's a stabilizer bar. So that would be 3 and 4. And then there's this linkage, I call it a fish mouth. That would be 5, 6, 7. So what's happening is the seat tube is not connected to what you might call the down tube, even though it's kind of elevated, and the rear stays. So this seat tube can go up and down, and it will. There's one spring and there's no dampening at all. So when someone rides the bike, it bobs. This is like a fish mouth, and with every pedal stroke, this is opening and closing. So the bike is constantly doing this as you ride, because no oil dampening, no friction dampening, nothing, just the spring. So this, I guess one of the features of the bike is that the relationship between the handlebars and the seat and the pedals, because they are hooked up to this frame here, it's a constant, it never changes. It's got a spoon brake. There's a brake lever up top here. Can you see how when I pedal, that's called a spoon brake. Now, if you're going downhill and it's raining or the roads are wet, I'd say good luck. When you need to adjust the chain, let's have a quick look at the chain. It's called a block chain. It was a precursor to what's now known as the roller chain. It doesn't have any rollers. A block chain, it was hard to find. I finally got one out of England. It was used on antique bicycles and also conveyor belts. It's a strong chain, it's heavy, and it'll pull a lot of weight. The chain, when you have to adjust it, you've got these axle adjusters back here, but to move this, you loosen the lock nut. You have to take out the axle, and then because this is at an angle, because the chain stays at an angle, you would have to go one whole turn, put the axle back in, lock the lock nuts. And when you're doing that, you're making the chain stay longer, and this part of the frame is bolted in there. So this part of the frame extends up to the head tube. So as you adjust your rear chain and the chainstay length, you are moving the head tubes out of line with each other. Maybe not by a lot, and I'm not sure how that affects things, but that's what's happening. I think that's one of the flaws in this design. There was nothing else like this at the time. So it was made from 1885 till 1888. In 1888, that's when Dunlop came out with his pneumatic tire, and that changed everything. That's when these bikes stopped getting made, because you didn't need all this sophisticated linkage and all that. Now you had air in your tires. I built this one with air in the tires because I didn't know where to get solid rubber. I was going to ride it, but I've got long legs. This is too short, so it doesn't fit me. And I looked at the photographs a lot, and I couldn't figure out how to really make the anchoring strong between this head tube and this head tube. So if I took the wheel, I won't do it, but if I took the wheel, I could move the handlebars. So that's why I don't ride the bike. It's just a show bike. If you look at the cranks, can you see there's a slot? You can move the pedal back and forth. So if you want a shorter crank, or if you got one leg longer than the other, that's a nice feature to have. I didn't know where to get a seat from. I didn't know what the seat looked like because in the photographs I had, it was just something which was really rotted out. So I went on the internet and I did a search for antique bicycle seats, and pages later I found a guy in England. His name was Tim Dawson, I believe. So I sent him an email asking him if he had knowledge or knew how to make a seat for an 1888 Whippet. And he responded by sending me a photo of himself riding his friend's Whippet. That's how I knew I found the right guy. So he made this seat and I made all the mounts. And then he asked me if I had pedals and I said no. So he told me about his friend in the Czech Republic who was making these pedals. And this is it's a reproduction of a high wheeler pedal. The high wheeler is the penny farthing or the ordinary, whatever you want to call it. It had different names. So that's where the pedals came from. It was pretty neat how it all came together. And I found a guy in Oregon. His name is Cody. He's a woodworker. And I got his card. He's a master woodworker. And I told him what I wanted. We talked about the shape, the arc, the finish, the wood. And then I said, well, I'll just get you to build me some wooden handle grips too. He says, oh no, I don't do that. So it's kind of interesting how he's a master woodworker. And the fenders came out really, really well. But I made these myself on my lathe. So I think these kind of projects that I get working on, I kind of came up with a name. I call it financial recklessness, where I start working on a project. I don't know how long it'll take. I don't know if I'll ever make any money off it. I don't know exactly how much it's going to cost. And so that is a kind of financial recklessness, but it suits my style and I don't have regrets because it was a great project working on this bike, and I'd do it again if I was in the same situation. In this video, we're going to show you how I made some of the parts. I can't show you the whole bike because that would just take way too long, but there's one thing which I can talk about. This brake rod here, it started out as a 3/4 inch rod, stainless steel. So I held this much in the lathe. So this was in the headstock, and I cut the thread and then I kept moving it up and making a taper, and then I had to bend it, and then I machined it, filed it. So it was a lot of work to make each individual part, because the only parts I didn't make really were the tires, the rims, the spokes, the chain. Didn't make the seat, but everything else I basically made. Here's the line drawing, or the artist drawing, which I found in the book. It's Bicycles and Tricycles, and this is what I worked off. I did a grid, made it full scale. I used 700C wheels, so I knew the size of the wheels. That's how I got the frame up to scale. I did this out of Frame Building 101, I think. I took a piece of chromoly tube, and I think I used 1 1/8" head tube. I cut up another piece of tube and brazed it all together. And that was how I started the frame. I soaked off the flux, I filed it up, and it looked okay. Here is the head tube, and it's got the down tube added onto it, and at the back, that round thing, that's where the 2 rear forks add onto. So I'm just got a kind of a makeshift frame jig. You can see I've got C-clamp there and big bolt and washer up by the head tube. That's how I did it. Here's the rear forks. You could call them, I guess you could call them the seat stays, although they're really heavy duty. I've got an axle in the bottom. That's the same length as the rear axle, and I've put some spaces in there. I've held it all with masking tape. And then that got held in the fixture as well. You can see I've got another C-clamp down here holding the axle, or the dummy axle, in place. And then I did some TIG tacking, and that's how that part of the frame all came together. Now we're going to look at the bottom bracket, how that happened, because that was kind of complex. There was a lot of different operations for that. It's not just one tube. I got some bearings out of the local bearing supply house. I figured out what size I wanted, and then I took a couple blocks of steel and I scribed the centers, and then that went into the mill. And I have a tube as well. That tube will go in between those two plates once they're machined. In the mill vise now, I've got the boring head going with a carbide cutter, and I've roughed out the hole for the bearings. Now, it's not a finished hole because there's going to be welding involved, and you can't, if you bore it out now, it's going to go out around. So these holes are probably a little bit undersized, maybe 30 thou. I've got the shape made, and I got the tube, and so that's going to get welded together. It'll probably get TIG tacked first and then brazed and filed, because back in those days they didn't have TIG welding, they didn't even have welding. They had casting, and they had a hearth where they could braze. They didn't even have oxyacetylene back then, not in the late 1800s. That was early 1900s. This little piece here, it holds the spring. So this goes onto the bottom bracket. So I had to make this first, and then this gets brazed onto the bottom bracket. You can see there, I've done some nickel silvering. It's still warm. You can see some redness. I made up a kind of a fixture holding everything together. This small rod at the back is the pivot for the chain stays. Nothing fancy. No bearings. There's just not room for bearings. And then I got a couple bolts and some of my hold down clamps off the mill. So it's going to get TIG tacked now. It got TIG tacked, it got brazed up. Doesn't look like I fillet brazed, it looked like I just run some nickel silver around there. I've got it in the lathe now, and you can see the boring tool. Now I've got to make it the right size for the bearing. It's probably size on size, so I got to use a little bit of force to get the bearing in there. You can see how this all fits together now. We've got the swing arm on the right. We've got the shaft where it hinges on. That gets pressed in. I think inside there I got some bronze bushings, if I can remember. Here's the mock-up of the frame. You can see that some parts have been brazed, and then other parts, like the top tube going to the seat tube, it's not brazed yet. So this is called a mock-up stage, where I'm just kind of figuring out if things are fitting. Do they need to be modified or tweaked very slightly? And this photo here is a close-up, so you can see all the different pieces that go into it. It is kind of complex. Took me a while to figure it out. So next we got the stabilizer bar. I don't know the real name for this. I call it a stabilizer bar because it keeps the seat tube in the middle of the stays. That's why it's so wide at the front. So here's the piece which the arms get welded and brazed onto. So I used a file and I rounded it. It would be hard to do that roundedness in a manual lathe, and I rounded it because that's what a casting would have looked like at the time. This here is a part of the arms. There's an arm on each side, and this is a bending jig which I made up, and I'm going to heat it up and I'm going to bend each of those two arms. The arms are bent, I've cut off the ends, and I've TIG welded them on, and you can see how that first piece that I showed you, it's inserted over the stabilizer tube. We'll call that a stabilizer tube. I've got it set up on top of the down tube now. It's held in the vise, and you can see I'm even using a spacer block and some masking tape. And these are the bushings where it has to pivot. And so I'll do a little TIG tacking there, then I'll take it off and I'll braze it. You can see now it's brazed. It hasn't been filed up at all. It's got the flux on it still. That's what it looks like when you soak it in hot water. The flux all comes off. That's when you can really see what the braze looks like, because the flux, it tends to hide But once it comes off, you really get to see how good your brazing is, or not so good. And that's the finished product. I'm pretty happy with how that turned out, and then it'll get a little bit more sanding, and then it gets sent out for nickel plating. And it's electroless nickel plating, and they only put on either 3/10 or half a thou. It's a very, very thin coating, but it's really durable, and it gives a beautiful finish. I started out with a couple slabs of bronze. You can see it's marked 954, and I was wondering if it was going to be a strong crank. So I looked in the specs. I got my metallurgy book out, and I found out, I was a bit surprised, 954 bronze has the same tensile strength as chromoly, 4130. So I thought, wow, that's kind of cool. So you can see here now I've got the holes here. This is for that's where the bottom bracket spindle goes, and this is where the slot's going to be for the pedal, and I've roughed out a shape. You can see hacksaw marks around here. It's in the mill. I'm taking off some weight. I got my face mill here. It's got carbide inserts. I've got an end mill. I'm cutting the slot. That's for where the pedals go. And then I needed to make a little relief there for that's where the nut goes, so it sinks under the surface a little bit. So I've got a fly cutter here. It's on the end of a boring bar, and I go back and forth with this single point tool, and I make a relief. So you can see this, what stage I'm at here. Now I need to take off some on the sides. So, because I'm not sure what kind of a shape I'm going for yet, because in the photographs it's really hard to see exactly what's going on. It's got black paint over top of it, and so I milled down the sides, and it definitely looked better, but I decided that I wanted a radius here. So I needed to do that, and I didn't know how to do that on the mill. So I got my porting tool out. It's got a carbide burr on it. I took a felt pen, I marked a felt pen line right down the middle, and then I put a radius on either side of my red felt pen mark. And then it was just a lot of hand filing just to make it smooth and to get that kind of a radius. So it's a radius this way and it's a radius that way. And then I did a bunch of sanding, and that's the finished project. I was really happy with how they turned out. I would say if I had to choose a word to describe them, I'd say they are handsome. I needed to make a pair of sprockets. I had the block chain. This is the block chain, came from England. And it took a little while. At this stage, I realized that I had to do some more calculations, and I had to figure out exactly what size and root diameters, that kind of thing. Underneath, on this photo, you can see a ruler. So the ruler is kind of showing the length of the chainstay, because I have to know what the center to center is, and I've also figured out how many teeth I'm going to have in each sprocket. I've got 9 teeth, and I've got 18 teeth. So I've got that all figured out, and so now I need a piece of metal. So I went in my bin and I found some 1/2-inch plate. You can see that it doesn't look anything fancy at all. It's actually hot rolled because it's got the scale on it, but that was how I started. I used an end mill. You can see the end mill here. I've got this on the milling machine. This is the rotary table, and I figured out how much of a cut I had to make. This obviously didn't happen in 15 minutes. I figured out what kind of a cut I made, how deep I had to go, and then when I came out, also the angle, so I would get the teeth at the correct shape. So that took a little bit of figuring. It was very handy that I chose a sprocket with 18 teeth, because then I got my 3-jaw chuck. I got the jaws reversed, so they're outside, so I've got 1 jaw every six teeth. So that worked out really good. So I took off some weight in the middle, I bored the hole, I put it up in the mill, and I used a hole saw, and the hole saw cut out out the lightning holes. After that, the hole saw leaves a little bit of a rough surface, so I used a boring bar, made a smoother hole, and that's what the sprocket looks like. It's not finished yet because I still have to put on the holders that hold the crank arm. I took some steel, it looks like 1.5 by 1.5 inches, and I cut out this shape, and I know that right now the shape isn't making a lot of sense, but you can see how it's got a hollow there. So that hollow, this is where the crank arm goes, and I'm making 2 of these. So out of this shape here, I get these 2 pieces. And that was a little bit of a challenge figuring out how to make those. I did a little tic-tacking. I got the spacing right. I put a crank arm in there. I did a tic-tac, and now what you see here, this is silver solder. There's quite a large surface area in between these 2 pieces. So silver solder was the best way to do it. I didn't have to use as much heat as nickel silver, and I didn't want to TIG weld it. They didn't have TIG welding back then. And that's what it looks like with the nickel plating. That's that Electrolyst nickel plating I told you about. That's probably about 1/2 thou nickel. We've got the big sprocket done, so I also had to make a small sprocket. So you can see it's definitely smaller. It's 9 teeth. Somehow I needed to get a freewheel into this sprocket. This is a freewheel on the left, and it's a BMX micro drive. It's a very small freewheel. It's a 14 teeth. So I needed to fit the freewheel into the sprocket. The first step was to bore it out. So it's this size is about the OD there, not including the actual teeth. And then I held it up on the rotary table in the mill. I took an end mill and I cut out 14 little recesses, because that's what's going to hold the teeth of the freewheel. See how it fits? I had to radius each of the teeth, because the teeth had to fit right in there. And this was the final step. I made up a cover, and I held it on with 5 little Allen screws. And you'll notice that the spacing is not equal, and that's because there is 5 screws and there's 14 teeth. In the lathe, I got some bronze, and it's not the same kind of bronze as the 954. It's more common. I don't know the number of it, but it machines a little bit easier, but it's still fairly strong. I made up a holder. This holder here, it's a piece of alloy, and it's bored to the exact size of the flange, so I can hold it really tight and I don't put any marks in, no chuck marks on this side. And tapping the holes, that was a whole nother thing, because a spoke is 2 millimeters, and then when they roll the thread, it becomes a 2.2 millimeter thread. But if you try and buy a tap, I don't think there's any in the world. You can buy a 2 millimeter tap, you can buy a 2.5 millimeter tap, but they don't make a 2.2, and the 2.5 is way too sloppy for the spoke. So I ended up using what's known as a 356 tap that's kind of close, and the spoke is still a little bit loose, but it's not as loose as a 2.5. So that's pretty nerve-wracking, drilling very small holes and then tapping, because if the tap breaks, you need to start all over again. So being very, very careful. It's the same sort of thing. I started with a block of bronze and I started machining. You can see here I've got the shape. What I'm doing now is I'm putting on the threads here, and the threads are going to be where the freewheel threads on, and then I made up a holder so that I could hold it, because I've got extra bronze out here to hold while I machine, so I needed a holder up at this end. I cannot just hold it on the thread. I've drilled all the spoke holes and tapped them. That worked out. So now I'm cutting off the excess bronze. This is in the bandsaw. I'm holding the bronze in a drill press vise. I'm finishing off the other end. I'm boring for the bearing. Then I'm going to add some shape here as well. Here it's got the freewheel on it, and it's mounted in the rear stays of the frame. Nothing's painted yet. and that's what it looks like. Radial spoking back in 1888. They had everything back then. This is the piece that goes onto the handlebar, and I made it out of 2 pieces of metal. I made it look like a casting. This is where the brake lever hinges, or the pivot is. There's a bolt that goes through here, obviously. This is the handlebar. I cut it in half, and I put it on because the ID is the same size as the handlebar, basically, and you see how it's got a radius on the bar. I can't slide it on, so I cut it, tic-tacked it, and then I brazed it all up and filed it up. So once the paint goes on there, you can't tell. This is what I started with. It's a huge piece of metal. It's about 3/4 of an inch thick and maybe 1 3/4 inches across. You can see I've got a cardboard shape in behind here. So I cut a V on the bandsaw. This is my arbor press, and I've set it up here, and I've got a heavy piece of flat bar on the bottom. I got spacers, I got C-clamps. This is the ram. And now I'm gonna add some heat to it. That's my big Tiger torch, and because that's a fair chunk of metal. That's gonna take some heat for sure. Mission successful. You can see the heat still in it, and it's bent. It got the bend I want. Otherwise, I'd be starting with a huge piece of metal. Huge. So this was the easiest way for me to make it out of 1 piece of metal and not weld it in the middle. I didn't want to do that. I wanted 1 piece. So I took it to the mill because when I bent it, it kind of bulged out on the side. So I've flattened it out now with a face mill. This is my cardboard template. I've got my machinist blue. You can see the scribe lines. So next I'll be heading over to the bandsaw. And you can see out of that 1 piece of metal, this is the brake lever in the middle. That's the shape that I want. Now it's a huge heavy piece now, so I've still got a lot of metal that has to be removed. So I put it on the mill, and I used a ball end mill, 5/8 ball end mill, and I milled it out. But then I took my high-speed grinder, and I got a cartridge roll, and that's when I can really make this shape smooth. And I can contour it. You can see here how it has to come back a little bit more. So I'll do that with this spiral roll. I've taken a hacksaw, I've cut down the sides. So now I've got a lot of grinding, filing, and all that. This is all done by hand. I think this brake lever, I think it was either 1 or 2 days work, probably 2 days work just to get it all cut. This is the brake lever. I've got it held in my lathe because I need to machine the end. The end needs to be rounded and it needs to be tapered. So I kind of like this shot of the brake lever in motion spinning. And that's the finished lever. It needs to get nickel plated now, but yeah, you can see how the end is round here, and then I scooped it as well. So that was fun making that brake lever. Never done anything quite like that. I need to make a seat post now. So this is the clamp that gets made out of bronze. This is 954, so this is the really strong bronze. It didn't need to be, but I had that bronze lying around, so I used it. So I've got the 2 holes drilled for the seat rails, and now I milled out the inside. I've got an arbor that's mounted in the chuck, and then I bolt the bronze onto that, and I cut a taper down. But I can only do so much on the lathe. I got to do some hand finishing as well. So you can see here how I've got a rough shape. Those are the same size as the seat rails. And I've got the bottom piece. I've done some fillet brazing in here. And this is just a nice piece of tubing that's the right size. And that's what it looks like when it's finished. I was really happy with the shape, how it turned out. I think it's got a good flow to it. I found out that the Whippet was made in London, England. There was a company and there was 2 partners. I think they're called L&B something. And I guess every bike was handmade back then, and I don't know how many bikes they made. I think in the world today there is maybe a dozen of them, and they're really rare. I've never seen one. All I've seen is photographs and drawings and books. So basically I made this off of photographs, We hope you've liked our episode on the 1888 Whippet full suspension. If you like it, if you subscribe, that'd be great. If you bought us coffee, that's the best. Mitch and I like good coffee. There's a little link below in Show More. I know Mitch will probably pop something up on the screen. Thank you very much. Have a great week. We'll see you next time. Stay safe.